The KTX-Blue Dragon, officially named KTX-Cheongryong, meaning Blue Dragon, in Korean, represents the newest generation of high-speed train service in South Korea. It was publicly unveiled through a naming contest. Its name was chosen to correspond with the year of the Blue Dragon, expressing hopes of grandeur, speed, and national pride. Manufactured by Hyundai Rotem, the train is a major achievement in domestic design and engineering. Nearly 100% of its design originates locally, and about 87% of the components are domestically sourced. The development process spanned many years, including research, design, testing, and adjustments. Part of this process involved addressing issues such as noise in the cab and passenger compartments, which led to redesigns, for example, modifications to pantographs and additional sound insulation. KTX Cheongryong officially entered service on May 1, 2024, operating on the Gyeongbu High-Speed Railway connecting Seoul-Busan and Honam High-Speed Railway towards Mokba-Gwangju lines. Its launch is part of a broader government strategy to reduce travel times nationwide, boost regional development, and improve connectivity so that many major cities become reachable within 2 hours via high-speed rail. Historically, Korea's high-speed rail service has included previous KTX models, including the KTX Sancheon and others. The Blue Dragon builds upon this heritage, incorporating new technology and design improvements to address the shortcomings of older models, especially in acceleration, passenger comfort, and operational efficiency. From its conception, the Blue Dragon was envisioned not just as another train but as a symbol of technological advancement, national capacity, and of reducing distance both physical and economic between Korea's regions. By improving travel times and comfort, it plays a role in promoting more balanced development across cities, making it more feasible for people to live farther from Seoul while maintaining access. In summary, the Blue Dragon marks a step forward for Korean rail: newer, faster, more efficient, more comfortable, an evolution built with Korean ingenuity, intended to serve Korea's geography, needs, and future ambitions. KTX Cheongryong is an electric multiple-unit EMU train set composed of 8 cars. Its car formation is 2 non-powered trailer control cars, 1 at each end, and 6 motored cars in between. This distributed traction design, power spread across multiple cars rather than concentrated in dedicated power cars, enhances acceleration and braking, which is especially useful on rail lines where station spacing is relatively short. In terms of speed, it is designed for a maximum commercial speed of 320 km per hour. Currently, due to infrastructure constraints, notably parts of the line not yet upgraded, it operates at up to 300 km per hour in service. Full 320 km per hour capabilities are expected to be usable once certain track works are completed. For example, the quadruple tracking between Pyeongtaek and Osong, scheduled to complete by 2028. Acceleration performance is significantly improved compared to prior models. The Blue Dragon can reach 300 km per hour from a standstill in about 3 minutes and 32 seconds, whereas older models like the KTX Sancheon took about 5 minutes and 16 seconds to do so. Some other technical dimensions and details. Length: approximately 199.1 meters. Width: 3.15 meters, wider than some older KTX models, which had approximately 2.97 meters, giving more space inside. Height: approximately 4.0 meters. Weight: approximately 437 tons. Axle load: reduced to approximately 15 tons from about 17 tons in older models. This helps reduce wear on tracks, lower maintenance, and better performance. Seating and capacity. Total seated capacity per train, 515 seats. One car is superior, premium class with 46 seats. The rest are standard class seats, making up 469 standard class seats. Seat layout. In both classes the layout is 2+2 per row. This is different from some previous models which had 2+1 in premium or different arrangements. Passenger comfort and amenities. Each seat is aligned with a window, that is, no double seats skip the window. This improves the view and feels more spacious. Electrical connectivity. Seats have 220 volts power sockets, USB ports, and wireless chargers. Screens, entertainment. There are large TV screens inside each car, 21.5-inch width. Other features. Improved legroom. The distance between a passenger's knees and the seat in front is about 126 mm in the Blue Dragon, compared to approximately 106 mm in older models. This makes longer rides more comfortable. Structural and design features. Car body is made of aluminium, which helps reduce total weight, improve energy efficiency, and reduce axle load. More soundproofing. Improved insulating materials on ceiling and floor. Changes in pantograph designed to reduce noise during operation. This was a response to feedback concerns during testing. Operational performance. Travel times are significantly reduced on major routes. For example, Seoul right-pointing arrow Busan with limited stops will take about 2 hours 10 minutes with Blue Dragon, compared to previous times which were longer. Yongsan right-pointing arrow Gwangju Songjung is around 1 hour 30 minutes. The train's braking and acceleration capabilities make it more suitable for lines with frequent stops, short distances between stations, so the benefits are not only in raw top speed but also in usability and travel time savings in real operating conditions. Infrastructure dependencies. Some of the maximum performance awaits infrastructure upgrades, most notably, completing quadruple tracks between Pyeongtaek and Osong by 2028, which will allow the train to safely reach its full commercial design speed of 320 km per hour. Until then, operations are limited to about 300 km per hour in some segments. In all, the technical design of Blue Dragon is pushing the edge of what is possible in Korea's geographical and operational context, combining high top speed, faster acceleration and deceleration, better passenger comfort, efficient use of energy, and maintaining safety and infrastructure sustainability. Impacts. What Blue Dragon means for South Korea. 1. Reduced travel times and better connectivity. With the introduction of Blue Dragon, major routes like Seoul-Busan and Yongsan-Gwangju are served faster. For example, Seoul to Busan can be covered in roughly 2 hours 10 minutes with limited stops, and Yongsan to Gwangju in about 1 hour 30 minutes. These reductions improve convenience, foster economic activity, and help people commute or travel more efficiently. 2. Regional development and decentralization. Faster travel helps reduce the dominance of Seoul by making outlying regions more accessible. People can live farther from the capital yet still work there, or more easily access services, culture, and economic opportunities. It helps balance development across regions. The government plans to make most of the country reachable within 2 hours. 3. Boost to domestic industry and technology. Because Blue Dragon is largely domestically designed and built, this is a major advancement for Korea's rail industry. It strengthens technical capacity, local manufacturing, and R&D. It also helps Korea position itself in the global high-speed rail market, whether for exporting systems or participating in international projects. 4. Passengers, comfort and quality of service. Improved amenities, more legroom, better connectivity, USB, wireless charging, quieter cabins, raise the user experience. These improvements not only make travel more pleasant but also can help shift more people from other modes of transportation, cars, buses, domestic flights towards trains, which are often more environmentally efficient. Challenges and limitations. 1. Infrastructure constraints. While the train is designed for 320 km per hour, many parts of the network are not yet upgraded to allow that speed safely or efficiently. The quadruple track section between Pyeongtaek and Osong must be completed to fully exploit the train's top speed. Until then, limitations in track capacity, curvature, signaling, and station spacing restrict operational speeds. 2. Noise and design adjustments. During testing, the Blue Dragon faced issues with excessive noise in both the cockpit cab and passenger cars. That required redesigns, modifications to pantograph, addition of insulation, etc. These delays increase development cost and postpone full performance. 3. Cost and maintenance. Building, operating, and maintaining high-speed rail is expensive. The initial investment in tracks, electrification, signaling, safety systems, and train sets is substantial. Maintenance also demands high standards, especially when speeds are high. Wear and tear for tracks, overhead lines, pantograph contact, etc., increase with speed. Reducing axle load helps but doesn't eliminate all cost. 4. Operational trade-offs. With many stops or closely spaced stations, the high top speed is less useful and less acceleration. Deceleration is also fast, which Blue Dragon addresses to some extent. Also, faster trains consume more energy, and the cost of electricity, safety margin, etc., matters. Also scheduling, managing capacity, and ensuring safety at high speed impose constraints. 5. Passenger cost and ticketing. Depending on fare structure, premium service, etc., there might be cost issues for passengers. If tickets are significantly more expensive for the speed improvements, some passengers might prefer slower, cheaper alternatives. However, the information so far suggests that fares for Blue Dragon services are not drastically higher than older models, though premium classes do cost more. Future prospects and possible developments. 1. Full speed realization. Once the quadruple tracking, especially Pyeongtaek-Osong, and other infrastructure upgrades are done by around 2028, Blue Dragon will likely reach its full service potential of 320 km per hour more regularly. That opens opportunities for trimming even more time off journeys. 2. Fleet expansion. As of early service, only 2 Blue Dragon train sets are in operation. More are planned. Additional sets, on the order of dozens, will be introduced by 2027 to increase frequency and capacity. 3. International competitiveness. With fully domestic design and manufacturing, Korea could use the Blue Dragon experience to export train sets or design services in other countries. The success of Blue Dragon could enhance Korea's reputation in high-speed rail engineering. 4. Integration with broader transport network. Blue Dragon works best when integrated with other transport modes, local transit, airports, bus systems. Improving last-mile connectivity, coordination of schedules, and ease of transfers will further increase its usefulness. 5. Sustainability and energy efficiency. High-speed trains are more environmentally friendly than planes or cars per passenger when well utilized. Increasing renewable electricity usage, further optimizing aerodynamics, lightening materials, and reducing noise are potential areas for improvement. Blue Dragon already uses aluminium body, reduced axle load to help infrastructure, and better insulation. These foundations can support future enhancements.